Hello everybody and welcome to your video notes on Learning Target 8.5 at the MEATS level, all about combination circuits and finding their totals. So what I mean by that is what's right here in yellow. I can determine the total resistance and total current in a combination circuit. So the question is, what is a combination circuit? Well, a combination circuit is something that is a circuit with series and parallel parts, and they are, wait for it, combined. Aha! That's where the word combination comes from. So we're trying to find current and resistance, and we don't need to worry about voltage because the total voltage is always given. If you think back to the basic level stuff, the total voltage is always given, so no harm, no foul, don't need to worry about that. This is what a combination circuit is going to look like. So if you look at the circuit, we can see that right here, this is parallel, and then these guys right here, that's in series, and oh look, we've got some series there as well. So this is why this is a combination circuit. It's because it's got a lot of different things that are happening in it. So let's talk about the rules, or the steps. Step 1, you're going to find the total resistance, and then there's going to be a 1A, 1B, and 1C. We're going to come back to those. And then step 2 is find current. Using Ohm's law. Okay, that seems pretty easy and pretty straightforward. So, hey, why is this going to be a MEATS level rather than a basic level? There's only 2 steps. The other things all had multiple steps. Well, it's because finding total resistance isn't quite as easy as it seems. So, let's look at that. So step 1A is going to be this. Combine any series resistors by adding. Okay, that's pretty easy. And then part B is the tricky one. We combine any parallel resistors using this equation. Let's go ahead and make this a different color because this is probably the most important thing about this video. 1 over R total equals 1 over 1 and so on. So this equation right here is, it looks scary, but I promise it's not as bad as it looks. But you've got your total resistance. So 1 over the total resistance of your parallel circuits is 1 over each of them added up together. And I'll show you how to do that when we get there. And then the last thing will be pretty much step one again. So combine we'll combine anything in series again by adding. What does that look like with this circuit over here? So step 1A says combine anything that's in series. So the first thing that we're going to do is we're going to combine R1 and R2 because they're series with each other, and then we'll combine R4 and R5. Okay, so what we want to do is we want to put these in and just make it into one resistor, because 100 and 100 is the same thing as just 200, right? So we can just make this simpler and simplify it and have less resistors, and that will make our lives easier. If we come over here, and we're going to say that we're going to do 1A. We're going to combine what's in series. So if we do R1 and R2, we end up doing 100 ohms plus 100 ohms. We get 200 ohms for that. And we can also do that for R4 and R5. We get 275 ohms plus this, and we end up with 500 ohms. Okay, and so I'm going to give you a hint here. We're going to redraw the circuit after a combining. Okay, so what that means now is these two are now going to be 1, and these two are now going to be 1, each with totals of 200 and 500. So what does that look like? So we're now going to have this. Pardon my beautiful drawing skills. So this is now R1 and R2 combined into a 200 ohm resistor. This one's still R3, with a resistance of 125 ohms. This one was R4 and R5, which together has a resistance of 500 ohms. And then this one's still R6 with 200 ohms. Okay, all that we did was we made this more simple and this more simple. Okay, so now we're going to do 1B, combine any parallel resistors with that awesome looking equation. I'm going to do this. Call this 1B. So the only ones that I have in parallel with each other are these ones. I'm going to combine R3 and R4 and 5 together using that cool looking equation. Combine parallel. I'm going to use this equation. I'm going to do 1 over R3 plus 1 over what I just decided to call R4, 5. Okay? So 1 over our total is going to be equals 1 over 125 ohms plus 1 over 500 ohms. Okay. Now this may look scary, but if you just type in 1 divided by 125 in your calculator, you end up with 0.008 plus 1 over 500 is 0.002 equals 1 over R total. And if we combine those two, we end up with 0.001 is 1 over R total. Okay, and then there are multiple ways you can solve this. There's some slick little calculator tricks you can do on your calculator. Otherwise, we can just use our algebra skills. So I want to, sorry about that. If I want to get this by itself, I have to undo the division with the multiplication. Where did that go? Let's try that. That's kind of funny. I have to multiply by something, but I can only multiply by what's on the bottom. So I'm gonna why does this keep happening? Go quick. Okay. 1 divided by that. Those go away. I'm left with 1 equals. I also have to multiply by R total. I'm left with 0.001 times R total. And then we divide by 0.001. This goes away. I'm left with R total equals 100 ohms. Okay. Step 1 complete. Okay. So, and again, this little algebra piece that I did here in the red, there's some slick math tricks that your teacher or me, I could teach you it, and you don't have to do all that algebra, but that's just one way to find the answer. Okay, we zoom out. We've done 1B. And now, okay, I shouldn't say step 1 complete. Step 1B is complete. Now we have to come over here and look at combine any series by adding. So what we just did is we combined these parallel ones into one circuit. So now we have this. Those are the 1 and 2 together, which was 200 ohms. Now this one was R3, 4, and 5 combined, and we got 100 ohms. And then this one's still just R6 at 200 ohms. So the final step for this is 1C. We're going to add up the series. Not secrets. Add up the series. So we've got 200 ohms plus 100 ohms plus 200 ohms. And we end up with 500 ohms. And there we go. And that is our total. Okay? So, now we just have to find the total current using Ohm's law. So here we go. I equals V over R. Our total voltage is 120 volts. I think I rewrote that wrong somewhere in here. I got that right. Oh, I got it right. Okay. So we got 120 volts divided by the total current, which is 500 ohms. And we get 0.24, there's the bell, amps. There we go. We got through that one. Okay, so now I would like you to find these three things with this circuit. I'm going to go ahead and put my answer up here in just a moment. So go ahead and pause it so you can do it on your own, and I'll show you the answer here shortly. All right, and here's what I got for my answers. I got my total resistance to be 412.5 ohms. I got my total current to be 0.109 amps, and then the total voltage was just 45 volts because of the circuit looked like in the beginning. That was given to us right away. So here's what you need to do. First thing, you got to do step 1A, which is combine anything that's in series. So I combined in R1 and R2, and I got 240 ohms. And then I combined R4 and R5 together, and I got 450 ohms. I then redrew the circuit, and this is what I got. I had R2, 1 and 2 was 240 ohms, which I just got, and then this one was combined. Everything else was the same. Then step 1B, I used this equation to combine those guys. So I did 1 over R3 and then 1 over R4 and 5, 1 over 150 plus 1 over 450. Get some really long decimals, and so I rounded them off a little bit. You want to keep as many decimals as you can. And again, there's some calculator tricks here that you can do. Otherwise, you can do the algebra that I showed you. But you get 112.5 for that total resistance. And then you come over here and you redraw the circuit as this. They're all in series. So then we can just add them up. And then that's how we got our total resistance of 412.5. Step 1 is now complete. And then we do our good old Ohm's law to get our current, as you can see right there. And again, our voltage was given. Thanks for listening.